In this video, I wanted to go over how to partition a line based on a certain ratio with a given ratio. We also call this a weighted average. So I'm going to give two methods of how to partition a line. The first method is what I call the fail-safe method, meaning I call it more the logic method. So if we're given a point 3, -4 for A, and a point B of 13, 11. And if I were to just draw this, I always like to kind of draw things just to try to picture what is really happening. So if we're at 3, -4, we're down here, 3, -4, that's our A. And our B is somewhere here, 13 and 11, let's say, kind of guesstimating here. So this is our point B. And let's say the question is asking us to partition the line in a ratio 2 to 3. So if it gives it like this, in this type of ratio, we say 2 to 3. What that means, and it will usually say from A to B or line segment. If it's written like this, that means A is the starting point, B is the ending point. And what that means is somewhere along the line AB, we are going to divide this into 2 parts and this into 3 parts. 2 to 3. So the first step is always to figure out, well, if it's 2 to 3, how many total parts is this? And in our case, that would be 5. So I like to call this, again, logic or triangle method. And to me, this is always what makes the most sense and is fail-safe because I don't have to remember a formula. But we're going to do the formula method also. That might be easier for you. So in this case, the whole thing is I need to figure out what my total x is. So I've gone from 3 to 13 for x. 3 to 13. So we just have to figure out how much that distance is, and we could do 13 minus 3, and that equals 10. So that whole distance for x is 10. Now I want to divide, I'm dividing this line into 5 parts, so I'm going to divide both the x and the y into 5 parts. So my total is 10. If I divide that into 5 parts, that is 10 over 5. 10 divided by 5 is 2. That means 1 part is 2 distance. So if we think about this, if I were to try to divide this into 5 parts, right, that would be 1, 2, 3, 4, 5. That means 1 part is 2, meaning this distance is 2. So I don't need 1 part, I need 2 parts because I'm dividing this into 2 to 3 ratio. So if 1 part is 2, 2 parts would be 4, right? 2 times 2 equals 4. So that means I'm going to go 4 away from my starting point. So my x value here at this point that I'm looking for would have to be 4 away from our starting point in the x direction. So that would be 7. So we know our x version, and we'll call this point P, our x value would be 7. So now I want to worry about the y. So my whole distance here is, I'm up here at 11, and I'm going all the way down here to -4. So that distance, we can either think I'm going 4 to 0 and then plus 11. That would be 15. Or we can think about 11 minus -4. That would also give us 15. So 15 is my total distance in the y. And again, I want to divide that into 5 parts. So 1 part would be 15 over 5. That means 1 part equals 3. And again, I'm deciding to go from the A. We could go 3 parts from the B, but since I already figured out the x direction, I'm just going to start with the A as well. So that means if 1 part is 3 in the y direction, 2 parts would be 6, because each part is 3 and I need 2 parts because I'm doing 2 to 3 ratio. So I'm going 2 parts up this line, 2 out of the 5. So 2 times 3 is 6. So from the A, y coordinate is -4, I need to go up 6. So from -4 plus 6, that would get me at +2. So that means my y value is 2. So that means this point that partitions the line A to B in a 2 to 3 ratio, the point P, would be 7, 2. And if we were to graph this or put it on a coordinate system, it looks like it matches. So that's the first way. So now let's do the same scenario, but let's do the different method. So I call this the giant equation method. This might also be called the weighted average. So again, if we have our point A, 3, -4, and our point B was 13, 11. So we don't have to draw this. I always like to, just because I like to visualize what I'm actually doing. So again, if we were somewhere here, this is A, this is B, I'm looking for my point that is 2 to 3. So they told me 2 to 3 ratio. So like we said, even in the first method, the second method, we still have to figure out how many total parts. So if they give this ratio, again, we would add the two numbers. And that means here is the big equation. What that means is this part, this is heavier. This is 3/5. 3/5 of the line. So I'm going to do the heavier part, or what I call the opposite part. Meaning if this is 3/5, I'm going to multiply it by A because it's the opposite part of A. For B, I'm going to multiply it by 2/5. It's the opposite. So I always just think it's the opposite of the point, of the endpoint that it's closest to. So 3/5 is the A, and I'm going to add that to 2/5 times the B coordinate. Now what's nice about this equation is that it gives you the coordinate. Before, when we were doing the triangle, right, we were really figuring out the distance. And then we had to add it to our starting point to figure out the coordinate. So I just like to point that out, that this is a little bit different method, and it gives us the coordinate. And what's nice about this equation is that we never even have to graph it if we don't want to. We can just plug it into this equation as long as we remember the equation. And the tricky part is just that we do the opposite portion for that endpoint. So B times 2/5, A times 3/5. So then we just plug in those points. So A was 3, -4, and B was 13, 11. And it's a little bit more math involved in this way as well. So if you remember, if we're going to multiply one point by this, I have to get to each of these. So the first two would be, if I just multiply fractions, that would be, and this is point P, that would be 9/5, comma, -12/5. I'm going to erase this, give ourselves a little bit more room. And we are adding, now if I do this math, 2/5 times each of these numbers. So 2/5 times, and we can just picture these are each over 1. So 2 times 13, that is 26/5. Kind of a yucky number, but I'm going to add, so that's okay if I keep them in fractions for now. 2 times 11, that gets me 22/5. And so if you remember, I can't add x to y, but I can add my 2 x's and I can add my 2 y's. And that is my P coordinate. So my 2 x's, I'm going to say 9/5 plus 26/5. 9 plus 26, that gets me 35/5. That's looking like a nicer number now. And then with my y's, negative 12 plus 22. Or we could think about 22 minus 12. That is a positive 10 fifths. So if we do those fractions, 35 divided by 5 is 7. 10 divided by 5 is 2. So we ended up with that same coordinate, 7, 2. And that was our point P. So it was the same result, but two different methods. So that is partitioning a line into two different ratios based on either a ratio or as a fraction. Please feel free to comment below if you have any questions.